In Section 1.2, we'll define several properties of matter, use those properties to identify substances, and talk about the differences between physical and chemical changes. Specifically, we'll talk about physical and chemical properties, intensive and extensive properties, and physical and chemical changes. Let's begin. Every substance has a definite set of properties, which are the characteristics that identify a substance. Properties that can describe or identify a substance without changing its chemical composition, such as color, melting point, and conductivity, are physical properties. The characteristic chemical reactions of a substance are its chemical properties. For example, we could describe the physical properties of iron as being a grayish solid at room temperature that conducts electricity. One of the chemical properties of iron is its tendency to react with oxygen to form rust. We can also talk about the extensive properties, which depend on the amount of substance present. Intensive properties are the properties of a substance that remain the same no matter how much sample you have. For example, it doesn't matter if you have a 1 kilogram gold bar or a 1 gram sample of gold leaf. The density of both will be 19.3 grams per cubic centimeter. While intensive properties can help us identify substances, extensive properties cannot because they change depending on the amount of substance you have. Let's try applying this information. If sample A weighs twice as much as sample B, is it possible to tell which sample is iron and which is powdered sugar? No. Weight is an extensive property and does not identify a substance. If sample A is attracted by a magnet and sample B is a white powder, is it possible to tell which sample is iron and which is powdered sugar? In this case, the answer is yes. Magnetism and physical appearance are both intensive properties and can be used to distinguish between two substances. The properties of compounds are constant and typically are different from the properties of the elements that compose them. Hydrogen and oxygen are both colorless gases at room temperature that can combine to form water, a colorless liquid at room temperature. The properties of mixtures are like the properties of the components that make up the mixture, but change depending on the amount of each component in the mixture. Dissolving 1 spoonful of sugar in a glass of water yields a sweet solution, a homogeneous mixture, while dissolving 3 spoonsful of sugar in the same amount of water yields a sweeter solution.
When the two gases are mixed, a spark will cause them to react. The atoms explosively combine as a pair of electrons become shared between each oxygen and 2 hydrogen atoms. A closer inspection of the inside of the container shows water vapor condensed on the cool container walls.
Physical changes do not alter the chemical composition of substances. Melting ice changes solid water to liquid water. Solid carbon dioxide, CO2, sublimes directly to the gas phase. Other physical changes include freezing, boiling, evaporating, and cutting or breaking a substance into smaller pieces. Iron and sulfur can be mixed, but remain iron and sulfur. They can be separated based on their different solubilities, which is another physical property.
Elemental iron filings appear as a black, shiny solid, and elemental sulfur is a dull yellow powder. When a magnet is placed next to iron in a test tube, the iron is attracted to the magnet. This is a physical property of iron. The sulfur is not attracted to the magnet, so it's not magnetic. The mixture of iron filings and powdered sulfur appears as a dirty yellow solid. When a magnet is introduced, the iron is still attracted to the magnet. Though some of the sulfur sticks to the iron, it is not attracted to the magnet. Mixing the two elements does not change the physical properties of each element.
Chemical changes cause the starting materials, or reactants, to rearrange their chemical compositions to form the resulting materials, or products. Iron and sulfur, when heated, react to form a new substance with properties that are very different from either iron or sulfur. Let's watch an example.
When a mixture of iron and sulfur is heated, the two elements react. Some sulfur is vaporized during the chemical reaction and is deposited on the test tube wall. The resultant solid is a chemical combination of iron and sulfur. The iron-sulfur compound is a dull black solid and is not attracted to a magnet.
We know that a chemical change has occurred because the physical properties of the products are often very different from those of the reactants. In the previous video, we saw how the iron reactant was magnetic, but after the chemical reaction, the iron-sulfur compound is no longer attracted to a magnet. During chemical changes, the bonds in substances are broken, often with a little help from energy absorbed from the surroundings, as in our iron-sulfur example. When bonds are formed, the process will release energy to the surroundings. This explains why chemistry studies both matter and energy. The two are intricately related. Let's try to think through another example. A pure substance is heated in air until no further reaction takes place. A different pure substance is produced that has a mass that is 58.5% of that of the original substance, so some mass was lost. Can you tell whether each substance in this reaction is an element or a compound? The product that was weighed has much less mass than the reactant, indicating that another product was a gas that escaped. Thus, the reactant is a compound that decomposes upon heating to produce two new substances. There is not enough information to tell if the products are elements or compounds. Let's try another example. After a different pure substance is heated in air, a new pure substance is formed that has mass of 138% of that of the original substance. Can you tell whether each substance in these reactions is an element or a compound? The product gained in mass, indicating that the original substance combined with a gas in the air. Thus, the product must be a compound. However, there is not sufficient information to determine if the two reactants are elements or compounds. As always, I'll leave you with the parting thoughts of the authors.